I want to start with a very simple question, which is what does a black hole sound like? And for some of you, this might be a familiar thing. You may have seen some interesting variations of listening to space, which when I first found out about it, just broke my mental model because I always imagined space is soundless, and that's clearly a myth. But here is a small piece, and I'll play it, and then maybe we talk a bit more. And now you know what a black hole sounds like. What's interesting about this piece is it's not just looking at an image of some space and then translating it into audio, but this is actually based on sound waves that were collected, which is essentially based on pressure. And there's some really interesting work that's been happening at NASA and many other space agencies where they're trying to take complex data about space and turning it into something that can be essentially transformed into audible hearing space, or like hearing range. And so you can start to interestingly consume things that otherwise would be, graphs, numbers, or interesting processes. And that's really what my talk is going to start with, which is information echoes. There is a lot of interesting ways in which data, which is predominantly seen in visual form, is now being explored in auditory and many other sort of modalities. And it doesn't just have to be things like this, which is complex data, but it could also be something more playful or personal. A quick bit about me, I'm Rasagy Sharma. For the last 13, 14 years, I've focused on making data sort of meaningful, which is by doing data visualization, charts, dashboards and stuff like that at companies like Microsoft, Barclays, Grameener, Mapbox, and then more recently at Capital One. However, about a decade into doing this, I kind of started getting bored because I was only making things inside a screen on like a two-dimensional space. So I went back to my design school, NID, where I decided to teach a very short module on taking data beyond 2 dimensions. What this really meant for most of my students was to make things like this. This is a project by Kirti. He took all the books that he owned and essentially arranged them in a way to encode whether he's read the book or not. And so suddenly I have a physical representation of my Goodreads read, unread list. He also then made it into a light installation in his room. So the more he reads, the more light comes into his room, the more illuminated he gets, right? So suddenly now data is turned into like light and, physical representation. Another student of mine, Parvati, she looked at her Netflix binge watching history, sort of counted every genre and how many times she was watching a particular episode, and then knitted a blanket so she can be a bit more cozy when she maybe consumes more Netflix, right? Both of these were tangible in nature. They were taking data from like a screen to something more physical. And then I had one student called Ritit who did something even more interesting. He decided to talk about his food ordering and delivery sort of data. And he's been stress eating since he came to Bangalore. He also started eating a lot more by ordering. And he wanted to, represent that feeling in an interesting way. And interesting is, again, understatement here. So here is what this project turned into. This is called Binge Beat. It's a sonification of his food ordering data for the last 1 year. Every time he ordered for a friend, there is that sound. A group is a doorbell. And then when he orders for himself, there's a boat. Now, the next bit is going to be extremely disgusting. And that is by design. So this starts with some of the time that he spent in Kolkata, which is his hometown. At that point, he's having food at home. There isn't any food ordering happening. So you see this nice beats. Every week is sort of represented by 2 bars. And then he moves to Bangalore, which is the college. And you start to notice some differences. So that was the first order that he made. More orders. Orders for friends. On his birthday, a huge order. And I'll not sort of torture you into hearing the whole piece, but you're welcome to listen to it. It's a lot of fun. And the reason why I think it's very interesting is, when was the last time a bar chart made you feel disgusted, right? And so this really got me excited about data sonification, and this idea that this whole field of turning data into sound could yield very interesting results. What I started to notice after I saw this project was that data sonification is actually all around us. It's not something that is only made in these like weird, quirky NASA space videos or burp sounds, but Slack notifications, data sonification. Every time an event is happening, it is communicating it with an abstract sound. Your typical clock. It's using a sound that mimics the real world, so the sound of the clock, and repeating it multiple times to communicate what hour it is. And even this sound, which I think some of you might be very familiar with. Yeah, that's a typical car sensor, which you would use in parking. And suddenly it's using a data set of how far the sensor is from a particular obstruction, and varying tempo and a few other volume-based properties of audio. These are three different techniques. So while the NASA space work is often audification, so they'll take a signal and they'll essentially transform it or squish it to make it audible in human range. Slack notification is an example of an ear con. It's essentially an abstract sound denoted, driven by data. The grandfather clock is an auditory icon. It is mimicking real world and then converting data to sound. And the car sensor is parameter mapping. It's taking data and then tweaking or mapping or controlling one of the many properties of audio that we can play with. While ear cons and auditory icons are super easy, they're also fairly limited because there aren't so many different sounds that you could make. But parameter mapping opens a huge world of interesting experiments. So here is what a very simple parameter mapping experiment would look like. This is done in a tool called Two-Tone. It's an online tool, very simple to use, and you can upload a data set like I have here, where this is Delhi's AQI data for roughly 2 years. And on the top, I have the average of PM 2.5 data. So this is one of the many aspects you look at in AQI. And the second is the average of SO2 data. What I've also done is map the PM 2.5 to a violin sound. So, higher it goes in octave, the more annoying somewhat it sounds, like it will be more sharper. And this SO2 sound, I could actually even filter. So I filtered and only kept the points where the SO2 was essentially crossing the mandated weekly safe limit. So every time it goes beyond the average weekly limit, you can hear some sort of a bass, in the background. So this is what it sounds like. Yeah, and so this is data of AQI turned into something that we could listen to. Now, one of the limitations of using tools like Two-Tone is, of course, that you're limited by a few instruments. And sometimes the data that you have may not really map to an instrument. Like if you're looking at something like AQI, which is not a very good thing, you don't want to make it sound like a violin or piano, etc. And so this is one of the limitations of easy to use tools, which allow you to plug and play things. But there's also a lot more that you start to notice. One, that it really just sounds like data sonification. Right? It's turning very clearly sounds into it. It isn't really pleasant to hear. And there is a variation between taking data and making sounds or noise, and then taking data and making it into music. And that's, I think, where a lot more understanding of music helps. A lot more custom sort of tooling also helps. And then a lot more mixing and matching of multiple data sets could also work. So while simple parameter mapping could just be a single data set turned into one of these elements, a more complex data set with multiple layers could also be used to really tune it well to form music. And I am no expert in making music, so I relied on somebody else who's a much better expert. So Miriam Quick and Duncan Gear, they are both been running this project called Loud Numbers. It started off as a small project, a podcast, it became a conference, and now I think they run a studio. And they've been turning a lot of data set into some really interesting music. So here is a small piece that I'll play, which is called Boom and Bust. It's also on their podcast. I'm happy to share links later. And it's a sonification of US economy. So they really wanted to think, what does money sound like? And they change the sort of sounds based on when economy is going well versus when it's in recession versus when it is out of recession. There's also multiple layers of other data like Dow Jones data added, some context like president's speech talking about economy, some small indicators of wealth gap, richest, poorest, expanding or collapsing. And then there's also some beats around US elections, which happen at a very regular period. So it's very easy to bring that into sonification. So I'll play a small bit of it, and then we can talk more.
This is Boom and Bust.
It's the economy, stupid!
Now you see the economy is shifted, it's descending. And now there is economy coming out of recession, so that on sort of comes in as well.
It will be essential for all of us to live and work in lower temperatures.
And then you have like a president's speech also overlaid. Now this, I think, comes much closer to what might sound like music, yet has immense amount of data enriched. However, it also makes it very hard to understand unless somebody really explains it piece by piece. So I recommend you to listen to their podcast where they first introduce every element, and then you can listen to the whole sonification piece, which is much longer, and actually start to notice some of these details, a bit better. So I want to conclude by highlighting when I think data sonification is a good choice and really why you should be using this. So in terms of when, it works really good for some specific kind of data sets. Of course, temporal data set very easily translates to sound, which is also fairly linear and temporal. If your data set is sequential, it also works really well. Periodic data tend to bring some rhythm in the sound that it is generating. And sometimes when it's a simple trend, it's easy to hear it as well. So the AQI one is very simple. It really increases, then falls, increases and falls. So it becomes easier to actually notice the pattern if I'm just listening to it and not seeing it at all. There's also some multidimensionality. So the one that we just heard has multiple layers of data added. And you can actually start to notice details once you get a bit more familiar with it. And there is a lot of opportunity to do real-time data sort of turned into audio live, right? So there's also that bit. And in terms of why, I think there is, of course, this emotive element. So for me, I love to see like playful data representation. So there is a lot more emotive aspect that comes in. I also think there's a huge accessibility bit. And I love some of the conversation that we were having just before my talk. And I think there is opportunity to take data visualization, which is predominantly only visual field, and make it accessible to many other sort of domains, right? It also makes it memorable. Like I'm hoping even today when we all go for lunch and if somebody burps, somebody will be thinking about it, it's data sonification. And the real-time nature can actually be very useful as well. So if you think about hospitals where there is a heart rate monitor, it is an example of data sonification. And it's even more useful because a person who is supposed to be running around the hospital may not always be looking at the screen to see the actual heart rate. And so the sound is a good way for you to focus somewhere else, but then notice if there is a change or there is a need for you to pay attention. But for, just to end it, it could just be for fun. And I'm going to end with some very simple piece that I've been thinking about and doing it for a data visualization conference that's upcoming in India, where we wanted to make a unique sort of signature for every attendee. And we wanted to make something visual first, but I thought, why not push it to also make something that is audible? So we did something very simple. We are mapping each letter to a position in the alphabet, vary the frequency a bit, and then we suddenly get interesting sounds for every name. So from A to Z, we're going to do frequency mapping. It'll sound like this. Fairly simple and straightforward. That means that my name, Rasagy, which has letters that alternate between end of the alphabet and starting of the alphabet, A and R, is going to sound like this. So suddenly I have a small tune that is my name. I could take Prashant's name, for example. And his name is interesting because it has two letters that are a bit more on the right side, and then one A, and then two letters and one A. So it has this 2-1-2-1-2 beat. Sunday we have something for Prashant, and we could probably also do it for the conference, right? So maybe next year, or when we do ADCx India next time, there is an audio that plays for every speaker for the conference, and it'll be somewhat like this. So with this, I'm going to try and end with some obvious stuff. How do I get started? For those who are interested, Two-Tone was the UI-based tool that I showed. P5.js is a very good intro to creative coding, and I've made the sound piece that I just showed you from names with p5.sound. There's also Tone.js, which gives you a lot more power. There is SonicPy and Pure Data that some of my other friends in creative coding and Algorave, etc., tend to use. And for folks who've done a bit more creative coding, there's also processing, which was a slightly earlier version, and it used to use Minim, which is also very powerful. I will share links to all of these resources on the right, but Loud Numbers is something I highly recommend if this has piqued a bit of your curiosity. There are some portals like Sonification.design, which actually archive a lot of data sonification examples. And then there is some sonification handbook. There are some people like Data Driven DJ, which have been doing a lot of experiments. And there's a nice NASA documentary called Listen to the Universe, fairly short video, which talks a bit more about space audification. And I want to end with this particular quote, which is most of us need to listen to the music to understand how beautiful it is. But often that's how we present statistics. We just show the notes. We don't play the music. And I think it works well for data visualization. It works even better for data sonification. And this is by Hans Rosling, who was a wonderful sort of data pioneer. And, his TED Talk is wonderful as well. Thank you. Any questions? Anybody is more curious about some of the work? I'm happy to talk more.
Yeah, thank you for the great talk. I'll probably I'll make that like my SMS tone or something. So every time I'm called, so I can listen to it. So my question is like, when you think about like mapping data, like when you used A to Z,
Yeah.
So as of now, you are changing frequency. Is it note based each sound? And how do you plan on other type of data? Like what note is it always musical? Is it always based on C major or some scale?
Yeah.
Or is it always frequency based where you don't have to worry about it to be like actually in
Mapping to
musical
like
notes and
exactly.
stuff like that? So how do you make a decision on that when you were exploring different types of sonification?
Yeah. So I think if you look at Two-Tone, it is a lot closer to actual sounds that make sense from like a synth or an instrument perspective. So all of this was like, I think it's C3 octave, the ones that I was playing with violin. The piece that I've made here for names is actually just frequency values. So I've just taken a name. I'll take each letter. A is given one number like 1, B is 2, C is 3, all the way to Z, which is 26. And I essentially take that range 1 to 26, and then I map it to, say, 600 hertz to 1000 hertz. And then I get a tune. So there, I don't think it is directly mapping to, say, a piano's exact frequencies or a pitch that I could control. But those would also be very easy to manage. I started with doing something very simple and playful. So it is using the bare bones of just frequency manipulation. But I have a whole oscillator which is essentially running, so I could always tweak it around to add maybe different aspects to it. There are other things that I would love to see. For example, if we do it for ADCx, apart from just the letters changing some sound, maybe there is some genre of music that might come in where we think about what is a person's area of interest, like we were filling in the form, and maybe that tweaks the sound itself, or maybe an instrument or some other style. So I think there are a lot of opportunities, and before we get into doing this for more formal use cases, I think it is important for us to play so that we start to notice which work, which don't work. So these are, I think, good experiments to play around with.
All right, thank you.
Thank you.
Any other questions? Hi, it's not really a question, but a comment because it gave me such a cool idea. Like as a composer, now this is a different way how you think about writing ideas. Because now you can look at text and data to create, melody lines, for instance.
Yeah.
So thank you for the inspiring talk. Yeah, it was very interesting.
Thank you. Yeah. And I am fairly noob at making music. So I would love to see what people who actually understand music a lot more do. And happy to always jam and help out, maybe build prototypes if that's helpful. Yeah.
Thank you. There's one more question.
Yeah.
Can you give some more examples of real-time data where it's performance dependent? For example, the proximity sensor is pretty cool where it changes your performance. So like, are there any stock traders who listen to the music of the market or anything else where it matters?
I have not seen stock traders listen to music, but I think that is going to save a lot of people's time, because otherwise they're always staring on the screens looking at stocks, right? And yeah, like I would pair it up with maybe notifications are easy for us to think about because that's something that we look at. But instead of visual notifications, turning them into audios would work great. There's this whole world of places where if it's a big factory, you would have a representation of all the factory's health in a way, in a single screen. Some of the work that I did at Microsoft was to visualize a data center's health. And that would be like an actual physical data center where we're looking at data and, if there's some errors, there's some things that are going off or not working. All of that was visual, which requires somebody to constantly look at a screen, which isn't practical. So I haven't yet seen very good practical example of somebody implementing it, but I do think sound for notification is fairly easy for us to maybe bring in. So if I was a stock trader, I essentially put all the stocks that I've focused on and give a threshold. And then whenever it goes below that threshold, it gives me a sound. Would be a very simple experiment to make. And would be a lot of fun. And because all of this is computational, it really makes it easy to take a real-time API and build some sort of a sound. I haven't seen examples. I will look for this. I am quite interested now as well on this.
So in trading companies, usually there is a squawk box as well, which keep announcing the price changes and like.
Yeah. So
that's not directly sonification as such for the data, but it's like the actual data there. But it's an augmenting your sensory input as well.
Yeah, I think even in general, the whole idea of dashboards that people tend to make could really be improved or enhanced by adding some sonification. And, if it's as simple as you're in, Myntra, Flipkart, and you have order history coming in, celebrating a particular set of orders and milestones are generally done with just numbers, make music out of it. So yeah, I'm going to look for more examples. Thank you for that, Naj.
Hi, thanks. So before this answering the question, I wanted to talk about the stock thing.
Yeah.
So we actually tried that. So what happens is when your stock is moving, there are certain frequencies involved in that. So what we thought in the graph, there are hidden frequencies. So we did some FFT response on that.
Oh, wow.
And we could find out what frequency it goes in when there is a certain movement in the stock. But then we could give it a sound now, as you said, as you also suggested. And then find out what kind of frequencies are involved in certain movements of the stocks. But it's not very conclusive. You need large amounts of data to understand, because every time one stock moves, there is a different frequency comes out, and then there is some other graph, other frequency comes out. But both are falling, so you don't understand really. Maybe deep diving is required. So thanks.
Yeah, I do feel just like visualization in a visual form sonification would also require a bit of getting used to, because it's a very different, like we don't listen to sounds and think a bit about pitch or think about, is there a frequency change or not. So I'm assuming anybody who spends a bit of time doing it learns to notice some of these patterns, or you use ear cons or audio icons to actually just say this shot up more than 15%. So then there is not so much of how much is the exact angle, but it's really threshold based buckets, and that becomes easier as well.
Okay, so coming to my question, so now I understand that you have assigned certain frequencies to certain inputs of the sensor.
Yeah.
Is there a now way to add emotion to it in a way that Indian classical music does? Like there are certain ragas which you listen only to the morning because there are lower frequency ranges.
Right.
And in the morning you don't like to really hear about high frequencies. So yeah, have you thought of anything about adding an emotion part of it?
I haven't, but I'm very excited about the keynote that's happening at 3. And I think we'll probably hear a bit more about Indian sort of music aspect of it. My sense is that it isn't as straightforward as just like lower frequency versus higher frequency leading to an emotion. But I've, like when I learned a bit of music, just this idea of komal sa versus like sa, like this variation between a single note changing how a particular piece is interpreted would be interesting. I haven't seen a good example of it yet where somebody could just say, take this data, sonify it, but make it sound happier or make it sound morose, right? So I would be curious about just this music principles that would go behind this before we can actually encode it. I have the whole frequency as my playground. So what I really need to now understand is it just discrete jumps? Is there variation between the discrete jumps that changes that emotional aspect of it? If there's some people here who've done a bit more research on this, I'm happy to pair up.
Hi. So I just have one question. Like the letter have been, noted to each note, right?
Yes.
Like, can we like also add a vocal bit to it, like a, like by a voice vocal bit, so that while playing the name, it'll be like a vocal tune.
That would be fun. I think it would work a bit better if we do this for languages which have, which are written the way they are spoken. So, for example, any Indic language like Hindi, right? It's easier to pronounce my name in Hindi because every letter and matra is essentially mapped to a sound. Whereas in English, cycle is my favorite sort of word to say, where the two C's have very different sounds, right? So if I'm going to say saisal or kaikal, it's going to be very annoying, right?
Like, is there some project working on like that, like where we can research upon that and then map it like that? Like,
So I think the way to then do this is not to use the name as we write it in English, but actually use the phonetic representation. And then that, I think, gets us closer to how it should sound. It would be more fun to not make it sound like how you anyway hear it, because then you're really doing a lot of steps to make it sound like, Rasagy directly.
I was just asking to integrate the thing that is already there and also the vocal portion.
Yeah. But I think it'll be interesting to mix a bit of the name. So if I do tell you a particular sound, like, let's just do this, right? If I did play this without telling you this is Prashant, I don't think we can hear this again. Yeah, but if I did play that same sound without telling you that this was Prashant or Rasagy, you would not really get the name from it, right? So it's easier to say that this is my name, so you understand my name and then make a sound with it, which is fun. But I don't think it works as I will tell you my name by just making a sound. So maybe some of the bits that you mentioned where you add a bit of letter for phonetic might make it a bit more recognizable as well. So I like that. I haven't seen a project that does this very seamlessly. I wish there were projects like this.
Thank you.
Making my life so much easier. I think we're running out of time.
We're running out of time.
Yes.
Time for the next talk. So maybe next speaker can take the questions offline.
Thank you.
Thanks, Rasagy, for that very fun talk.